Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. In today's video we're going to look at how we use a multiplexer to implement a Boolean expression. And so we're going to start from a truth table, and then from that truth table we're going to use a multiplexer to implement that truth table, if you will. So let's get started. So we have there we go, multiplexer Boolean expression implementation. Essentially this is a function implementation. So I'm going to write down a function here for this 3-input truth table. And it looks like that. So if we're going to use a multiplexer to implement this function, one of the first things that we're going to do is we're going to divide this up into rows of 2, like so. And the reason why we're going to do this is because we're going to use our multiplexer with 2, in this case we have 3 inputs. So we're going to choose selectors that are one less than the number of inputs. So we're going to choose one with 2 selectors. Now 2 selectors designates it to be a 4-to-1 mux. And so we're going to use a 4-to-1 mux. So let me just kind of show you why we divide it into groups of 2. So in this group of 2, we can see that x is 0 and y is 0. So the selectors are 0, 0. In this one the selectors are 0, 1. This one, the selectors are going to be 1, 0, and this one, the selectors are going to be 1, 1. And so we're going to make S1 X and S is 0 Y in our mux. Okay, so that's the first part. Divide those rows up into 2. And so next part we're going to do is we're going to compare the Z row and the F row, the Z column and the F column, like this. So we're going to compare these two. And so what I can see here is that when Z is a 0 in this first set of 2, when Z is a 0, F is a 0, when Z is a 1, F is a 1. So we're going to say that F is equal to Z under the conditions that x is equal to 0 and y equals 0. So this is when. And another way to say when x and y are equal to 0 is when we're selecting I0. So S1, S0 are both 0, right? We're selecting I0, and in that case, F is equal to Z. And so if we're going to pass I0 to the output, if we make I0 equal to Z, then when it's selected with input 0, 0, then those will pass that out to Z. And I'll show you that a little bit more clearly once we draw the circuit for that. So let's do that for the rest of these. So 0 becomes a 1, 1 becomes a 0 for the next set of 2 when S is 0, 1. And that corresponds to when x and y are 0 to 1. So F is equal to Z bar in this situation. In this case, no matter what Z is, the output is 0. So we'd say F is just equal to 0 here. And in this case, it doesn't matter what Z is, F is always equal to 1. So F is equal to 1. So this is when x equals 0 and y equals 1. And so we're selecting I1. This is when x is equal to 1, y is equal to 0. So that's I2. And this is when x is 1 and y is equal to 1. So that's selecting I3. So let's go ahead and draw this now. So I'm going to use the standard block diagram here for a mux. Actually, I don't like that so much. I want to try something here because I heard you could do this. Let's see. Oh, hey, that's nice. I like it. Okay, cool. So this is going to be selectors, and we always start with the lowest value, S0 and S1, okay? And here's the thing, we have to make sure that we apply these right, because some people would put X on top and Y next, and that would be wrong. See, S1 is X, the most significant input goes with the most significant selector. So S1 is going to be X, and S0 is going to be Y. So we're using our first two inputs as our selectors for our mux. Okay. And now we have 0, 1, 2, and 3. Those are our inputs, I. I are 0, 1, 2, or 3. Okay. And then we just have one output, and that is F. So we have our F. Okay. So what are we looking for? So when I is 0, so when there's I 0, that corresponds to these first two rows, F should equal Z. And so what we'll do is we'll take a Z and put it into I0. So when we select I0, so this is X is 0, Y is 0, Z is 0, right? Then we have X, Y, 0, Z is 0, F should be 0. So it's passing through Z, so it is 0. And when it's 0, 0, 1, we're selecting this, and Z is 1, and it should be a 1. So that makes sense, okay? And then we have Z bar, and that goes into 1, like that. And then 2 is always 0, so what we're going to do is we're going to connect it to 0 volts, which is ground. And then 3 is always 1, so we'll connect it to 5 volts. So this will go to a 5 volt signal, okay? And so that is how we use a mux to implement a Boolean expression. We have to, again, step by step, we have to divide these into rows of 2. All right, divide them into rows of 2. Actually, here, I'll just make a little procedural bullet point here. So divide truth table into groups of 2 rows. Use all but the last input as selectors, right? And then look at last input and the output to decide mux input values. Okay, hopefully that makes sense. So yeah, we divide it into groups of 2. We use the first n whatever number of inputs we have to make our selectors. And then we use our last input with F to decide how they relate. And then we implement that as the inputs to the mux itself. And then it'll pass it through for the next one, okay? We're gonna do an example, so let's go ahead and take a look at an example. So I'm gonna make this a bigger truth table. So let's go ahead, we'll do 4 inputs. So here's our example. And let's go 1, 1, 0, 1. Let's go 1, 0, 0, 0. And then we'll go 0, 1, 0, 1, 1, 0, 1, 0. Okay, great. So first step, divide these into, let's see, maybe I can use some of these other tools. Is that going to work? I can move it over here. It's probably going to take longer. That's not bad. Divide these into rows of 2. Okay, so that's done. And then we are going to choose our selectors as all of the inputs except for the last one. So these will be our selectors, right? So I'm just going to highlight those first few. And then we take a look at the comparison between the last input and the output F and see what they equal and how they relate. So I'm going to do that. So F equals 1, F equals Z, F equals Z bar, F equals 0. So how did I get those first 4? Well, the output's always 1, no matter what Z is, so it's independent of Z, it's a 1. This one, the F is equal to Z because 0Z is 0F, 1Z is 1F. And in this one here, it's the opposite, so it's Z bar. This one is always 0, independent of Z, so it's always 0. And then here we have F is equal to Z, F is equal to Z, F is equal to Z bar, and F is equal to Z bar. So if you haven't noticed, these are 4 options: 1, 0, Z, or Z bar. So we've written all of these out now. So let's go ahead and draw the block diagram and implement this. Got me excited there. That's lots of fun. So now we have W, X, and Y, and so we have 3 selectors, and this is an 8-to-1 mux. Now remember, this is where the big mistake happens with my students, is that they write from the top, W, X, Y. But the reality is that W is the most significant, so it gets S2. And so it's going to be W, X, Y in that fashion. Take note, okay? So make sure you're doing it that way. Now we have 7 inputs. 0, 1, 2, 3, 4, 5, 6, and 7, okay? And so what are those input values going to be? Well, we've already written them out. We have 1, Z, Z bar, Z, Z, Z bar, Z bar, and then we have that 0 there. So I'm going to start with a Z. And so Z goes into 1, but it also goes into, let's see, this is 0, 1, 2, 3, 4, 5, 6, 7. So Z goes into 1, 4, and 5. And so let's go ahead and copy that down to 4 and to 5. Now we have a Z bar, so let's go ahead and make a Z bar. Z bar goes into 2, 6, and 7. So Z bar goes into 2, and then also into 6, and then also into 7. Great. And now, just so we don't get confused, I'm going to change this color here to a blue. And we have a 1 for 0. So here we go. A 1 is going to be for us 5 volts. And then we have a 0 for 3, which is going to be ground. And there we have it. And then we have our output F. So it's really pretty easy once you get the hang of what you're supposed to do. And so if you're using a mux, you don't need all those other logic gates. You just have to put in whether you got Z, Z bar, 1 or 0 into each of the inputs of the mux. And then we use the rest of our inputs for our truth table to select the proper input for the mux and pass it along to the output. that's it for today. Thanks for watching. I hope you enjoyed it. I hope you found value from this video. My name is Mike Stanzik, and this is Digital Electronics Classroom. As always, please like and subscribe. Really appreciate that. Have a wonderful day.